Okay, exercise 702 is the gradient formula. Now, they actually don't write the gradient formula in your textbook, but I'm going to give you the gradient formula anyway. Now, we know that gradient, the symbol for gradient is m, which is rise over run. And basically, the rise is the change in your y values, and the run, so when you rise, going again, the gradient, symbol m, is rise over run. When you rise, you're looking at the difference in y values. And when you run across, because the x-axis goes across, you're looking at the change in the x values. Now, to make sure that you get the sign of your gradient correct, whether it be positive or negative, the way we do gradient, change in y values, I'll explain this in a minute. We've got y2 over minus y1 over x2 minus x1. In other words, if I've got 2 points and I want to work out the gradient between those 2 points, I call this first point x1, y1. In other words, this is point 1 down here. It doesn't matter if you put point 1 down here or point 1 up there. It doesn't matter. And up here, I've got point 2, so I call it x2, y2. So point 1 has an x value and a y value, which is why it's called x1, y1. And point 2 has an x value and a y value, which is why it's called x2, y2. Notice the 2's and the 1's are subscripts, not superscripts. They're not powers. They're sub, x sub 2, x sub, y sub 2. They're subscripts. All right, it's different. Like in maths, if you put x and the 2 up the top, that's x squared, y squared, and it's not that. So I'll just do an example in a minute. For example, if you wanted to find the gradient, you would just do this y value minus this other y value. See, y2 minus y1, and then you do this x value minus this x value. The reason the formula is y2 minus y1 over x2 minus x1, we don't want you to subtract the y values one way and then subtract the x values the other way, because you'll get the sign of the gradient incorrect. So if you're going from top to bottom, you have to go from top to bottom. y2 minus y1, x2 minus x1. Or you could go y1 minus y2, x1 minus x2. As long as you do both the x's and the y's the same way, you're okay. But if you do one of them one way and subtract the other one the other way, you will get the sign of the gradient incorrect. So just some examples. First one is to find the gradient of these lines. So I know I don't have a grid here, but if a line passed through the point 2, 1 and a line passes also through the point 4, 5, look, I like to make the point lower down, my point 1, and the higher one, point 2. So this is an xy value, so I call this point x1, y1. Do you get it? And I call this point x2, y2. So my gradient is change in y values, y2 minus y1 over x2 minus x1. So I've labelled each point x1, y1, not x1, x2. That is an x and a y value. This is point 1, that's point 2. It doesn't matter if you call the top one point 1 or the bottom one point 1. But I like to have the one that's lower down as point 1, all right? So what's y2 according to this? 5 minus, what's y1? 1. So we've got 5 is y2 minus 1 over, so I went 5 minus 1 over 4 minus 2. x2 minus x1. Look, it's that one minus this over that one minus that. Going the same way. The top minus the bottom, the top minus the bottom. The y's first, then the x's. And what do we get? 4 over 2, which is 2. So therefore, the gradient of that line is 2. It's a positive gradient. Okay? I'll do another example with some negatives. I'll do question 1D. Find this gradient. So you've got 0.68 and 0.106. First thing you do, you label the points. Okay? So I'm going to call the top one 2.2 and the bottom one 0.1. Now, I can do it both ways for this one if you want. Because you might say, well, if I call that 1.1 and this 1.2, I'll show you that you get the same answer. All right? So we're going to go from top to bottom, and then I'm going to do it over here, bottom to top, okay? And you'll see that we get the same answer. Gradient is y2 minus y1 over x2 minus x1. Okay, let's go. Change in y values. What have you got? 8 minus 6 over 6 minus 10. Now, I've got 2 over, what's 6 minus 10? Negative 4. A positive divided by a negative is a negative, so it's negative a half. So the gradient's negative a half, and it does. That's a negative gradient. The first one, notice, was a positive gradient. Now, what happens if you decided to do y1 minus y2 over x1 minus x2? It doesn't matter if you did bottom point to top point. It doesn't matter. You will get the same answer. All right? Some people don't like to use the formula. They just do this y minus that y, that x minus that x. So let's do it the other way. What if you call this your other point? What's 6 minus 8? So I'm doing it in the opposite direction. So I'm going y1 minus y2 over x1 minus x2. So I've gone bottom minus top, bottom minus top. What do I get? Negative 2 over 4, still a negative, negative a half. So it doesn't matter which one you call 0.1 and 0.2, whether you do y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2, it doesn't matter. You will get the same answer, but just make sure you go the same way. It's either top minus bottom, or bottom minus top, bottom minus top. Because one point will always be higher than the other, unless it's a flat line and you've got a zero gradient. Okay? You have to be really careful if you've got negatives. Now this is negative 5, 4. I'm going to call that x2, y2. It doesn't matter but if it was x1, y1. And then down here I've got negative 1, negative 4. I'm going to call that x1, y1. So my gradient is y2 minus y1 over x2 minus x1. Someone's just asked a question if this was on the graph, which is a good question. So if this is xy, xy, if I think of how we were doing it last lesson, rise over run, if you want to see what the rise is, you look at the y values and it's going from 6 up to 8. So that's a rise of 2. And if you want to look at the run, it is going backwards and it's going from 10 to 6. So that's going down, which is backwards 4. So it's 2 up, 4 back. I mean, you can look at it like that, but you've really got to be careful if you do it like that when I come to this third example down here. All right? So let's look at that third example. See, this is up 2 and backwards 4. See, we got 2 and 4 back. All right, now, if I look at this one, let's see if you can guess how many up, how many back. See, you're going up from negative 4 through to positive 4. Just think, if you're going from negative 4, you have to go through what? Through 0 and then up to positive 4. What's this rise if you did do it that way? Yeah, it's a rise of 8. And if you ran backwards, you're going from negative 1 to negative 5, which is just backwards 4. So it's 8 over negative 4. But we'll use, so that is a rise up of 8, and running backwards of negative 4, you would do it like that on a grid. I mean, you can do it like that this way as well, but you just got to be careful that you don't mix up the x and the y values. So we're looking at 8 over negative 4. We're expecting a gradient of negative 2 here. So let's try it with the actual values. So y2 is 4 minus, see, when you see the negative, please, you just write whatever that is, minus, and now look at what y1 is, and it's negative 4. So you have to put the negative. Over x2 is negative 5. I write my minus sign, and then I look at what x1 is, and it's negative 1. Please don't be afraid if you've got minus and negative. And don't ignore it if you've got the negative. All right? So you write down what y2 is, you put your minus sign, and then you look at what y1 is. And if it's got a negative, you put it. Because it's obviously different to if it didn't have a negative. And then you write down what x2 is, negative 5 minus, and then you look at what x1 is, negative 1, and you write the negative again. So when you see two negatives, what do? 4 plus 4 over, this is still negative 5. It's only when you see two signs together that you fix it up. Negative negative is plus 1. 4 over 4 is 8. Negative 5, 5 down, 1 up, that's negative 4. A positive divided by a negative is a negative. So the gradient's negative 2. Okay? Or I could have subtracted the other way round, but I'm not going to. All good? Okay, you can also be given a table of values. This is the table of values where you've got for this x value, that's the y value. So when x is 0, y is negative 1. When x is 4, y is 11, etc. Find the gradient of the line represented in the table. What you can do, this is the point 0, negative 1. And here we've got the point 4, 11. So you can just write the points out separately. And you can go, that's x1, y1, and that's x2, y2. So what is the gradient? It's the change in the y values over the change in the x values. I mean, you can just do it from the table. You can go, or you can do it from here. If you do it from the table, you'd go this y value minus that y value. Does that make sense? Over this y value minus that y value. Or you can write the points out separately and go y2 minus y1. What's that? 11 minus, now what's y1? 11 minus negative 1 over x2 is 4 minus 0. So 11 minus negative 1 is 11 plus 1, which is 12, over 4, which is a gradient of 3. Now, you know how we were looking at what do the y values go up, and we were working out the gradient that way? We can't do it today because the x values are going up by 3. Okay? But notice the x values are going up by 3 and the y values go up by 9. That means that if the x values were going up by 1, the y values would go up by 3 anyway, and that's what the gradient is. But look, just choose y2 minus y1, you can, or you write your points out individually. Would you prefer to do it from the table, 11 minus negative 1, 4 minus 0, or write them out individually? It's up to you. But that is a point, and that's a point. Or you could have used one of these points as well. Any points that you want. As long as it's 2 points, and the points don't have to be next to each other either. I could have done 1029 with 411. If I wanted, I would still get the same answer. Okay? Because if I did these two, I'd get 29 minus 11 is 18, over 10 minus 4 is 6, 18 over 6 is also 3. So it doesn't matter whether you choose these 2 points, these two, this with that, that one with this, doesn't matter. As long as you've got 1 point and another point, you will get the same answer. While we're here, what's the equation of this line, therefore? Remember, y equals mx plus b. Can you see the y-intercept? That always occurs when x is 0. Well, I've got it there. So I'm going to say, well, my y-intercept is when x is 0. So therefore, the y-intercept, which is b, is what? Good. And I know that my gradient, because I just worked it out, was 3. So therefore, the equation of this line is y equals, what do we got? 3x. My y-intercept is negative 1. mx plus b is the equation of a line. What's the b? Minus 1. Okay? All right, copy that down. Just clarifying here, y-intercept is when x is 0, so you look at the table. Now, you won't always have when x is 0 from the table, all right? But if you do have x is 0 in the table, you can automatically see the y-intercept. So from the table, we can see that the y-intercept is -1. The reason I'm writing b here is that when we write the equation of a line, it's y equals mx plus b, so therefore my b will be -1 when I substitute it in. So therefore, replacing m with 3 and b with -1, we get y equals 3x minus 1.